to prove that z of n to the power p is equal to the next property. What we are going to generalize the multiplication by n property is prove that z of n to the power p is minus z into d dz of z transform of n to the power p minus 1. जैसे z ट्रांसफॉर्म ऑफ n स्क्वायर निकाला तो z ट्रांसफॉर्म ऑफ क्या यूज किया था, n. So similarly z transform of n to the power p will be obtained by taking the derivative of z to the z of या z transform of n to the power p minus 1. What is p? P is nothing but the positive integer, and hence deduce this. These results are already available. I need to just generalize or verify this statement and try to get the answer, or try to validate the answer whether it is coming out equal or not. By definition of z transform, we have z of n to the power p is summation n equal to 0 to infinity n to the power p into z to the power minus n. So z outside, why I am doing this? See, I want the term as n plus 1 because I will be using the definition. So accordingly मैंने adjustment क्या कर दिया, z to the power minus n into z to the power minus 1, and to cancel this z to the power minus 1 I will be multiplying by z to the power 1. So this z to the power 1 comes outside, and this minus n minus 1 comes together, and it is giving you minus n minus of n plus 1. And definition of n to the power p minus 1 क्या आएगा, n to the power p minus 1 into z to the power minus n. I have to bring this on the right hand side, then only this particular result will be valid, right? So do the adjustment here. What is the adjustment to be done? In the RHS, whenever it is z to the power minus n, multiply by z, and to cancel it, multiply by z to the power minus 1. Z to be taken outside the summation because n नहीं है उसमें, और ये जो है -1 इसको जोड़ दीजिएगा -n के साथ. So -n minus 1 will become minus of n plus 1. So accordingly we will be getting, and this is all we need to keep in mind, that this is the definition of z transform of n to the power p minus 1. जिस किसी का भी z ट्रांसफॉर्म लेना है उसको z टू द पावर माइनस n से मल्टीप्लाई कर देंगे. नाउ इक्वेशन 1 जो है ना, इसको दोनों साइड्स अपने को लाना है, इसका डिफरेंशिएशन, एंड टू बी फिटेड इनटू द इक्वेशन 1 आपको आरएचएस में क्या लाना है, डेरिवेटिव ऑफ z टू द पावर z ऑफ n टू द पावर p माइनस 1. इसको डिफरेंशिएट करके वी ट्राई टू ब्रिंग इक्वेशन नंबर 1. सो डिफरेंशिएटिंग बोथ साइड्स, derivative on the left will be d dz of this, on the right hand side derivative of z to the power minus n क्या होता है, माइनस n into z to the power minus n minus 1. और आपको अभी समझ रहा होगा why this adjustment we did, because we tried to fit this into this particular form, and hence from 1 and 2 we try to get the desired result. So once, what you need to remember over here, in the very first step where we are calculating z transform of n to the power p, do the adjustment of z to the power minus 1 multiplied by z, and then as per the definition of z of n to the power p minus 1, we try to differentiate the both sides, and then inside the summation it will be fulfilling the condition or the definition for the z transform of this, and therefore we try to get the result as z to the power z of n to the power p as minus z into d by dz of z to the power z of n to the power p minus 1. यहाँ पर आपको ये रिजल्ट जनरलाइजेशन का देगा. n to the power p, any power of n is multiplied, उसके 1 पावर लेस का z ट्रांसफॉर्म का डेरिवेटिव इज नथिंग बट द आंसर. सपोज आपको अभी n स्क्वायर का निकालना है z ट्रांसफॉर्म, तो आपको n का z ट्रांसफॉर्म पता होना चाहिए. यू विल बी कैलकुलेटिंग द डेरिवेटिव ऑफ दैट एंड मल्टीप्लाइंग बाय माइनस z. सिमिलरली n क्यूब का निकालना है तो n स्क्वायर का पता होना चाहिए. नाउ यू कैन वेरीफाई. सो p इज इक्वल टू 1 अगर पुट करोगे, if you put p is equal to 1, you get z of n as minus of this, which is already obtained. P is equal to 2, that is giving you the answer for n square. So for z of n square, derivative of this particular term, whatever we have got over here, you are getting the same answer. So ultimately, for multiplication by t property or generalized property of n to the power p, आपको previous वाले term का z transform पता होना जरूरी है. वो अगर पता है, differentiation of that will give you the answer. Now, on the similar lines, where we have discussed the property related to the multiplication by n, I will now talk about the property related to division by n. So in every property, what is important? This definition or statement is needed that z of f of n is f of z. It fulfills the definition of z transform. Then prove that z of f of n upon n is giving you the integral z to infinity f of z upon z dz. Now मुझे बताइए, can integral be obtained directly as per the definition of z transform? No, integral cannot be obtained directly as per the definition of the z transform. Like in the earlier case, what we have done, we have differentiated both sides. Similarly, here also we will have to integrate both sides and then we get the answer. So z of f of n is summation n equal to 0 to infinity f of n into z to the power minus n. Division by n property, as per the definition, it is f of n upon n z to the power minus n. नाउ z टू द पावर माइनस n को इंटीग्रल में ऐसे कन्वर्ट करेंगे, क्योंकि व्हाट इज इंटीग्रल ऑफ z टू द पावर माइनस n माइनस 1 1 प्लस होता है. सो माइनस n माइनस 1 प्लस 1 अपॉन माइनस n माइनस 1 प्लस 1, यानी z टू द पावर माइनस n अपॉन minus n. And if you put the integral z to infinity as per the question or the result, आपका आंसर क्या आता है? z to the power minus n upon n. So f of n as it is, z to the power minus n upon n is together written as integral of z to the power minus n minus 1 between the limit z to infinity. Now integral को थोड़ा सा साइड में करो, n वाले टर्म्स को टुगेदर लाइए and summation, that will give you the definition. So 1 by z will be inside the integral and summation will be taken over f of n and z to the power minus n. ये z to the power minus 1 को क्या लिखा मैंने? 1 by z, and we transferred it outside the summation because summation is over n. So I am getting the answer as integral z to infinity 1 by z multiplied by summation n equal to 0 to infinity this. What is this? This is the definition of z transform. So क्या बचता है? इंटीग्रल z to infinity 1 by z f of z dz, यानी इंटीग्रल z to infinity f of z upon z dz. And I think this was only the result, which is r. So as per the definition, after simplification, क्या दिमाग लगाना है कि z transform after integration result should be minus n. तो इंटीग्रेशन में उसका इंटीग्रेशन माइनस 1 के पावर के साथ होगा, बिकॉज इंटीग्रेशन एड्स अप, वो ऐड करेगा एक पावर. सो इंटीग्रेशन z टू इंफिनिटी z टू द पावर माइनस n माइनस 1 dz का वैल्यू z टू द पावर माइनस n अपॉन n, provided it is integrated between the limit z to infinity. I have given the simplification for that and it fulfills the value. Now z to infinity can be simply written as integral over z, क्योंकि इंफिनिटी यानी ओपन एंडेड है, आखिरी वैल्यू पता नहीं, या आपको पता है whenever the limits changes minus is multiplied, so it is minus times integral over z, या integral from z to infinity is written as minus times integral infinity to z f of z upon z dz. So similarly on the lines of multiplication by n property, I am calculating or I am looking up to the division by n property. Is this point clear to everybody? यहाँ तक clear है बेटा सभी को? Multiplication by n property and division by n property, is this clear to all? The next property what we are going to talk about is shifting property. Shifting property is also to be discussed into two parts: shifting property to the left, shifting property to the राइट, जैसे मल्टीप्लीकेशन बाय एन, डिवीजन बाय एन, shifting property to the left, shifting property to the right. So initially we talk about the shifting property to the right. What is this shifting property to the right statement is, if z of f of n is capital F of z, then z of f of n minus k. N minus k means positive number when it is shifted, right? So ऑन द नंबर लाइन जब पॉजिटिव नंबर्स का शिफ्टिंग होगा तो माइनस साइन आएगा, नेगेटिव नंबर्स का शिफ्टिंग होगा तो लेफ्ट में प्लस आएगा, n प्लस के आएगा. इट इज z टू द पावर माइनस के इंटू एफ ऑफ z, वेयर n इज ग्रेटर देन इक्वल टू k, और f ऑफ n माइनस के इंटू u ऑफ n माइनस के. यूनिट स्टेप सीक्वेंस यहाँ पर लगाया है. इट इज ऑल्सो इक्वल टू z टू द पावर माइनस के इंटू एफ ऑफ z. सी, on the number line we have the positive numbers k plus 2, k plus 1 and so on. So subtraction अगर लोगे shifting to the right तो subtraction आएगा, नेगेटिव नंबर्स का शिफ्टिंग अगर करोगे तो प्लस आएगा. So shifting to the right will deal with the property or the value z of f of n minus k. So how to go with it? As per the definition, z of f of n minus k is summation n equal to 0 to infinity f of n minus k into z to the power minus n. Summation n equal to 0 to infinity. Again do the adjustment. I have multiplied by z to the power minus k, and to cancel that it is z to the power positive k. Z to the power minus k is outside the summation. N summation is over n. So what is remaining? F of n minus k into z to the power minus of n minus k. Now I want the definition of the z transform to get fulfilled. So put n minus k is equal to m. जब n equal to 0 रहेगा, m will be minus k. जब n equal to tending to infinity रहेगा, m will be infinity. So f of m is equal to क्या हो गया? Z to the power minus m into summation m is equal to minus k to infinity f of m into z to the power minus m. But I know that we are talking about only right-sided z transform or one-sided z transform whose value starts from 0. So minus k से लेकर 0 तक सीक्वेंस क्या रहेगा, या फंक्शन का वैल्यू या सीक्वेंस का वैल्यू क्या रहेगा? 0. एंड फ्रॉम 0 टू इंफिनिटी it is f of m into z to the power minus m, right? Because for the negative numbers our value of sequence is not existing, because I am considering the case of only one sided or right sided z transform. So 0 minus k से 0 तक 0 आएगा, 0 से infinity तक वो value है f of m into z to the power minus m. And what is this actually? This is fulfilling the definition of the z transform. So z of f of m is z to the power minus k into f of z. But what was m? M was n minus k. So I am getting the result over here as z of f of n minus k is z to the power minus k into f of z. Z of sequence is also written in this way. F of n minus k is equal to z to the power minus k into f of z. So in this way we calculate the proof